I will speak about angle between two lines in this lecture. Okay, if let us say two lines are parallel to each other, what will be the angle between these two lines? 0 degrees. If two lines are perpendicular to each other, what will be the angle between these two lines? It will be 90 degrees, right? In this particular article, what I am going to take is two lines which are non-parallel and not perpendicular to each other, right? And these two lines are non-vertical lines. What I mean here is that L1 or L2, both these lines are non-vertical, because vertical lines have undefined slope, right? Their slope is not defined. But here in this expression, in this article, I am going to talk about angle between two lines in terms of their slopes. So if I am going to talk about L1 and L2, let us say their slopes are M1 and M2, and angle between these lines can be this angle or this angle. Okay, and we also know that these two angles form a linear pair with each other, or in other words, these are supplementary to each other, right? So if we know about one of these angles, we can find out the other one also. So let us not worry about phi for a moment and think about this theta. Let us say this line L1 makes an angle of inclination alpha 1 and L2 makes an angle of inclination of alpha 2. Now if you look at this triangle here and this exterior angle alpha 2, we can say that alpha 2 is equal to sum of opposite interior angles, which are alpha 1 and theta, right? So what can you say about theta? It will be equal to alpha 2 minus alpha 1. Now I am going to talk about angle between the two lines in terms of their slopes. So let me take tan theta, and it will be equal to tan of alpha 2 minus alpha 1, right? And what is tan of a minus b? It is equal to tan a minus tan b divided by 1 plus tan a tan b. And what are tan alpha 1, tan alpha 2? These are slopes of lines L1 and L2. So let me write it in terms of M2 and M1. M2 minus M1 divided by 1 plus M1 M2 will be the expression for tan of theta. So this is the tan of angle between these two lines, M2 minus M1 divided by 1 plus M1 M2. But for now we have got tan of theta. Let us talk about phi now. We know theta plus phi is equal to 180 degrees. So theta will be equal to 180 minus phi. Now I know about tan of theta. So tan of theta will be nothing but equal to tan of 180 minus phi. And tan of 180 minus phi can be written as tan of minus of tan phi, right? Tan 180 minus phi can be written as minus tan phi. So tan phi is negative of tan theta. All right, from here you should have written that phi is equal to 180 minus theta. So tan phi is equal to tan of 180 minus theta, which makes it minus tan theta. This way or this way, both give me the same result, but this could have been more convenient. Okay, so tan of theta we know is m2 minus m1 divided by 1 plus m1 m2. So let me put it here. Tan of phi is equal to minus tan theta. So what is tan of phi in terms of m1 m2? Minus m2 minus m1 divided by 1 plus m1 m2. Now see, I could have written m1 here and m2 here and not written this negative sign, but I have written it for a purpose to explain it to you something. So this expression, and what was tan theta? It was m2 minus m1 divided by 1 plus m1 m2. Now this expression and this expression, these are same. Okay, what if this is positive? There can be two cases. Either this m2 minus m1 divided by 1 plus m1 m2 can be positive. Okay, so if this is positive, let us say, so what can we say about tan theta? Because tan theta is equal to it, so we can say that tan theta is positive, right? And what is theta? Theta is angle of inclination, so it lies between 0 and 180, right? This is angle of inclination that we are talking about. And if tan theta is positive, so we are talking basically about these two quadrants, first and second quadrant, where theta can lie, right? And if tan is positive, so we know that theta will lie in the first quadrant. All right, so if this expression is positive, tan theta will be positive, hence theta will be acute, right? And if theta is acute, what about phi? Phi is 180 minus theta. Phi is 180 minus theta. So phi will be obtuse. In case this is positive, right? You can find it out from here also. If this is positive, and here I've got this negative sign, so tan of phi will be negative because of this negative sign. Okay, so tan of phi is negative, that means phi is obtuse, because then the angle of inclination will lie in this second quadrant. All right, so phi is obtuse in this case. Now another case can be when this m2 minus m1 divided by 1 plus m1 m2 is negative. If this is negative, then tan of theta will be negative, hence theta will be obtuse in this case, and phi will definitely be acute in this case. Okay, now this expression is negative in this case. Now I am writing 1 plus m1 m2 1 plus m1 m2 in the denominator, so I should mention that 1 plus m1 m2 is not equal to 0, right, for this to be positive, because if this is 0, then this will not be defined. But I did not care to write this expression because I explained in the very beginning that we are not talking about two lines which are perpendicular to each other, because this is the case. 1 plus m1 m2 will only be 0 if the lines are perpendicular to each other, because in that case m1 into m2 will be negative 1. Slopes will be negative reciprocals of each other, right? So this was about this. Now if we want to write in terms of only acute angles, let us say theta is acute. Okay, till now I did not consider theta or phi to be acute. Now let us consider theta is acute. So if I want to write an expression for tan of theta in terms of the slopes, I'll put this modulus sign here and write m2 minus m1 divided by m1 1 plus m1 into m2, because tan of theta has to be positive. So if this expression is positive or negative, if I put this modulus sign here, this will give me positive result. So tan of theta is positive in this case. Now theta is acute angle that we are talking. So if we are talking about acute angle, then tan of theta we will write as mod of m2 minus m1 divided by 1 plus m1 m2. And just by looking at this expression also, you know that theta will be, if theta is 0, what will happen? Tan 0 will be 0, so the numerator has to be 0, hence m1 will be equal to m2. The slopes are equal, which we have already discussed. If theta is 90 degrees, let us say, then tan of 90 is not defined. Why? Because the denominator becomes equal to 0. So 1 plus, if theta is 90, that means the denominator 1 plus m1 m2 is 0. So m1 m2 is equal to negative 1, which we have already discussed that in case of two perpendicular lines, their slopes are negative reciprocals of each other, right? So now let us take one question. If, let us say, angle between two lines is pi by 4 and slope of one of the lines is 1 by 2, then the slope of the other line will be what? Now we know that the angle between two lines is given as pi by 4, which is an acute angle, right? So let me write tan of pi by 4, tan of angle between two lines we know is mod of m2 minus m1 divided by 1 plus m1 m2, where m1 and m2 have taken as slopes of these two lines. Or we know that one of the slopes is 1 by 2. So let us say m2 is 1 by 2. Okay, so we need to find m1 here. What is tan of pi by 4? It is equal to 1. So let me put m2 equal to 1 by 2, and it will be 1 plus m1 into 1 by 2. So the expression that I've got here is 1 minus 2m1 divided by 2 divided by 2 plus m1. So the 2 in its denominator and 2 here will get cancelled, right? So it will be equal to 1. Now mod of this expression is equal to 1. So this expression can either be 1 or it can be minus 1, right? In both the cases, mod of this expression will give you 1. Now solving these, we should get the values of m1. So if I solve this expression here, it will give me 1 minus 2m1 equals 2 plus m1. Okay, so minus 2, if I bring on the right hand side, will become 3m1 here, and this 2 goes on the left hand side, it will give me minus 1. So from here I can say m1 is equal to minus 1 by 3. m1 is equal to minus 1 by 3. So this is one of my answers. And if I solve this expression here, or this equality, 1 minus 2m1 is equal to minus 2 minus 2m1, minus 2 minus m1, right? And if I bring this on the right hand side, 2m1 minus m1 will become m1. If I bring it on the left hand side, 1 plus 2 will become 3. So this is another answer. Now I've got two answers for the slope of the line that we are looking for, right? And if you notice, these slopes are minus 1 by 3 and 3, which are negative reciprocals of each other. So the lines, these lines are perpendicular to each other. So let us see what can be the situation. We are given this line here, okay, and let us say this was the given line. So we have found slope of this line, let us say, which was inclined at 45 degrees with this line, okay. But now see, there can be another line like this which is also inclined at 45 degrees with this line. So there can be these two lines which are inclined at 45 degrees to this given line. That is why we have got these two answers, and these two slopes are negative reciprocals of each other, which will mean, like, this is 45, this is 45, so this angle will also be 45. Now look in this triangle, this is 45, this is 45, so this angle will be 90 degrees. So these slopes are negative reciprocals of each other because these two lines that we have got as our answers, or the slopes of which lines have we got as my answer, are perpendicular to each other. Okay, so this was about angle between these two lines. Now in this example, we are given the information that there is this line which passes through these 2 points, and there is line perpendicular to this line which passes through these 2 points. So these two lines are perpendicular to each other. So what can we say about their slopes? That the product of their slopes will be equal to minus 1. So let us say these two are the points through which line L1 passes with slope m1, and line L2 passes through these 2 points with slope m2. So what I am going to do here is I will find slope m1 and slope m2, multiply these and put them equal to minus 1, put the product equal to negative 1, and then I'll find this value of x. So slope of line L1, which is m1, is equal to 8 minus 6, that is y2 minus y1, and divided by x2 minus x1. So 4 minus minus 2 is 4 plus 2. So 8 minus 6 is 2, 4 plus 2 is 6. So it is equal to 1 by 3, and m2 is equal to 24 minus 12, that is this y2 minus y1 divided by x minus 8, divided by x minus 8, right? Now these two slopes are of perpendicular lines, so their product should be equal to minus 1. So let me put their product equal to negative 1. 24 minus 12 is 12, 12 divided by x minus 8. So m1 into m2 is equal to negative 1, which implies 12 by x minus 8 into 1 by 3 will be equal to minus 1. Okay, so this will become 4. 4 will be equal to negative of x minus 8. So this implies x minus 8 will be equal to minus 4. So x will be equal to 4. So this is your answer. Collinearity of 3 points. Collinearity of 3 points. So we are discussing about collinearity of 3 points. Okay. Now we know that slopes of two parallel lines are equal, right? Slopes of two parallel lines are equal. Now if there is a situation that two lines have got equal slopes and a common point, then these points that we are talking about will lie on same line, right? So these 3 points will be collinear. What I mean to say is, if let us say AB and CD are parallel to each other, then their slopes will be equal. Now consider a situation where AB and BC are given to you, right? So AB and BC, that means these two lines AB and BC, these have got equal slopes. Then what will be the situation? AB and BC has got equal slope. Now this is A, this is B. Then C will have to lie on this line, because AB and BC have got one point in common, that is B, and they have got equal slope. So this line AB and BC have got equal slopes, and B lies on this AC. So A, B and C are collinear points. I hope I have been able to explain it to you that to test the collinearity of 3 points, two conditions are enough. That if these 3 points make two lines, right? A, B and BC, let us say we have got 3 points A, B and C. So A, B and BC if I take as two lines, or A, B and AC if I take, right? So any two line segments if I take, if they have got equal slopes, then we can say with certainty that these 3 points are collinear to each other. Okay, so let us do a question based on that. Now in this question there are 3 points P, Q and R, and they lie on a line, so they are collinear, and we need to show that this is equal to this. So for P, Q and R to be collinear, let us say they lie on the same line, P, Q and R. So if they lie on same line, we can say that slope of PQ will be equal to slope of QR, right? So let us put their slopes equal to each other and see whether we can find this expression or not. So slope of PQ will be equal to y1 minus k divided by x minus h, x1 minus h, sorry, and it is equal to slope of QR, that is y2 minus y1 divided by x2 minus x1, right? So now we required this expression because if I cross multiply, I'll get the required expression. So you cross multiply it, y1 minus k into x2 minus x1 will be equal to y2 minus y1 into x1 minus h. Okay, and this is what we require in our answer. No, we require h minus x1 here and k minus y1 here. So we can write it as k minus y1, so we will have to write it as h minus x1. So, or in other terms, you can say we can multiply both sides by -1. So if you multiply both sides by -1, you can change this as k minus y1 into x2 minus x1 equal to y2 minus y1. Then you'll have to change this to h minus x1, which is what we were looking for. Okay.